Okay, hello everyone. In this video, we will be talking about the geometric sequence and geometric series. Let's begin with the geometric sequence. A geometric sequence is a sequence that has a common ratio that is given by the formula a sub n equals a sub 1 times r raised to n minus 1. A sub n here is the nth term of your sequence. A sub 1, that's the first term of your sequence. R is the common ratio, and the same value of your n here will be the value also of your n in the left side. So for example, I have here a sequence 1. Let's write down example. I have here sequence 1, 3, 9, and 27. Our a sub 1 is 1, our a sub 2 is 3, our a sub 3 is 9, our a sub 4 is 27. Now let's verify this one if this is a geometric sequence. We can have that by the formula a sub 2 divided by a sub 1, a sub 3 divided by a sub 2, and a sub 4 divided by a sub 3. So our a sub 2 is 3, a sub 1 is 1. We have 3 divided by 1, that's 3. A sub 3, that's 9. A sub 2, that is 3. So 9 divided by 3, that's also 3. A sub 4 is 27. A sub 3 is 9. So 27 divided by 9, that's also 3. Now we do have a common ratio, which means this example or this sequence is a geometric sequence. Now let us try to look for the fifth term of this sequence, a sub 5. So we will look for the fifth term of this sequence by applying the formula. A sub n will be replaced by a sub 5 since we are looking for the fifth term. Our a sub 1 is given by the value 1 times the common ratio we have here 3 raised to n, that is 5, minus 1. So we are left with 1 times 3 raised to 4. Since 5 minus 1 is 4. Now we have 1 times 3 raised to 4 is simply equal to 3 times 3 times 3 times 3, or multiplying 3 by itself 4 times. Now let's just use the calculator. We have 3 times 3 times 3 times 3, that is equal to 81. Now we have 1 times 81, or simply 81. Thus, the fifth term in this sequence is equal to 81. But we can also do that by simply multiplying the common ratio to the last term in the sequence. We have 1 times 3, that is 3. 3 times 3, that's 9. 9 times 3, that is 27. And 27 times 3, we have here 27 times 3, that is 81 also. So our fifth term is 81. You can use the formula or even directly multiply the ratio to the last term. And that way you will still have the same answer. Now, if we do have a geometric sequence, we also have a geometric series. The geometric series is the sum of all the terms in your geometric sequence. Now let's refer to this example and let's look for the sum of the first five terms of the sequence. So this will be S of 5 since we are looking for the sum of the five terms. Our A sub 1, that is 1 times 1 minus the common ratio is 3 raised to n, which is 5. So we have here all over 1 minus 3. Let's continue. We have 1 times 1 minus 3 raised to 5. That is just multiplying 3 to itself 5 times. So we have 81 times 3, that is 243. No, or simply 3 times 3 times 3 times 3 times 3, that is 243. All over 1 minus 3, that's negative 2. Now we have 1 times 1 minus 243, that's negative 242, all over negative 2. And that's 1 times negative 242, that's negative 242 divided by negative 2. 242 divided by negative 2, that's positive 121. Take note that negative divided by negative, or like sign having the operation which is division, you will have a positive outcome. Now let's try to check that one if we will manually add the 5 terms. So in this sequence, the terms are 1, 3, 9, 27, and 81. These are the first 5 terms of the sequence. So let's add them. We have 1 plus 3 plus 9 plus 27 plus 81. The answer is 121. So you see the same lang gihapon ang answer. That's up to you. But then again, it will be less hassle, less time consuming if you will just use the formula. If we are talking about bigger numbers now, like for example, go and look for the sum of the 99 terms of the first 99 terms in the sequence. So that's up to you kung unsay mas ganahan nimo na way. Alright, so that would be all for this video. I hope that you have learned. If you do have questions or suggestions, drop it in the comment section. Bye bye.